After 9 years of traveling through the solar system, when NASA's New Horizons spacecraft finally reached Pluto and sent back the first images of the far-flung world, we saw something that absolutely blew our minds. For decades, Pluto had been a planet of paradoxes. Once considered the 9th planet in our solar system, it had been reclassified, debated, and wondered about. The object had remained a blurry dot even in our most powerful telescopes. But now, after more than 80 years of its discovery, we had the first close-up pictures of Pluto. The spacecraft showed us a Pluto filled with geological features that indicated not just a history of activity, but the possibility of ongoing dynamism. Towering mountains, deep valleys, and vast plains suggested a world in the process of changing, not a fossilized relic from the past. But the most surprising discovery was the strong evidence of a subsurface ocean concealed beneath layers of ice. This finding didn't just make us reconsider Pluto, it threw open new doors of possibility for the existence of life beyond Earth. If a so-called dead planet at the far reaches of our solar system could harbor an ocean, what else might we find as we venture deeper into the cosmos? The discovery of a subsurface ocean on Pluto was puzzling and raised some critical questions. How could an object more than 4 billion miles away from the Sun, with a temperature of negative 380 degrees Fahrenheit or negative 228 degrees Celsius, have an ocean underneath its surface? What's really happening inside Pluto that's creating an active geology on the distant world? Finally, and most importantly, after all we found on that world, why do some astronomers want the IAU to reconsider the planetary status of Pluto? Just as New Horizons broke barriers in our understanding of Pluto, it's important to break down the barriers of language, expanding our own personal horizons right here on Earth. Let me introduce you to the sponsor of this video, Babbel, one of the top language learning apps in the world. Have you ever found yourself lost in translation while traveling? I remember navigating a bustling market in Barcelona, trying to ask for directions. Instead of saying, "Where's the train station?" I accidentally asked where the train sleeps, eliciting laughter from the locals. So why did I choose Babbel to master Spanish? For starters, their lessons are scientifically proven to have you start speaking a new language in just 3 weeks. That's a transformation almost as dramatic as the one New Horizons sparked in our understanding of Pluto. The lessons are also designed by real language teachers, not algorithms, which for me is a game changer. Plus, Babbel offers live classes, giving you 2 live free classes with your subscription. It prepares you for practical scenarios, from business discussions to ordering food in a quaint Spanish cafe. ¿Quieres empezar? As viewers of The Secrets of the Universe, you get 60% off on your subscription by clicking the link in the description. So let us know what language you would like to learn in the comments section. The answers to the mystery of the subsurface ocean on Pluto lie in its past. According to one of the widely accepted theories, it was long believed that Pluto had a very cool beginning. As we know, during the formation of the solar system, the protoplanetary disk composed of gas and dust provided the building blocks for planet formation. Just like most other planets, Pluto also formed during the early stages of the solar system's development, approximately 4.6 billion years ago, in a region beyond Neptune known as the Kuiper Belt. The Kuiper Belt primarily consists of icy materials, such as water ice, methane ice, and other volatile compounds. It's possible that different ices in this region collided and merged over millions of years. Gradually, they clustered together enough to form a larger body the size of Pluto. Furthermore, since the temperatures here are much colder than in the inner regions of the solar system, these ices remained relatively undisturbed. Eventually, this resulted in Pluto having a cool start. Over the years, Pluto's internal heat would have melted some of its ice, creating a subsurface ocean. Now, this theory works well to explain Pluto's subsurface ocean. However, here comes a twist. Approximately 2 years ago, when a team of researchers decided to test this hypothesis, they realized that a cold start might not be the case at all for this dwarf planet. Instead, new geological observations of Pluto's surface suggested that it began with a hot formation scenario. It experienced a rapid and violent formation involving a series of massive impacts similar to those experienced by early Earth. But how did geological features that the New Horizons spacecraft saw shed light on Pluto's formation scenario? Well, this can be understood through a simple phenomenon that we observe in our everyday lives. The vibrational energy of a molecule depends on its temperature. So, when temperatures drop and water freezes, the vibration of water molecules also decreases. This results in the formation of a less dense crystalline structure. Following this behavior, water expands as it freezes and compresses as the ice melts. If you want to see a demonstration of this, consider placing a glass of water in the freezer and allowing the water to freeze. You'll observe that the glass may break due to the expansion of the water. However, please exercise caution and ensure supervision when performing this experiment, as it can be dangerous. Now, turning our attention to Pluto, it becomes clear that if it started out hot and then gradually froze, its surface should have expanded. Consequently, this expansion should be evident in certain geological features on Pluto. Conversely, if Pluto had a cold start and then warmed up, its surface should display features indicating compression. When the research team closely examined the observations made by the New Horizons spacecraft, they were astounded by what they discovered on this far-flung world. To everyone's surprise, there were no apparent signs of compression, while features indicating expansion were clearly visible. This was evident in all the impact craters on Pluto, including those located in the oldest terrains, which appeared stretched out. The presence of a subsurface ocean also tells us how quickly Pluto must have formed. How? Well, if Pluto had a violent beginning with successive large impacts, the heat generated by the explosions would have continued accumulating within the dwarf planet's interior. This, in turn, would have facilitated the maintenance of Pluto's internal ocean in a liquid state. However, for an ocean to develop this way, Pluto must have formed rapidly, likely within a mere 30,000 years. This is because each impact would have acted like a small explosion, heating the surface where it struck Pluto. If Pluto had formed slowly, the surface would have cooled down before the next impact could occur. Conversely, in a scenario of rapid formation with simultaneous impacts building upon each other, the surface would have become hot enough to give rise to a liquid ocean. Additionally, this concept aligns with a study suggesting that Kuiper Belt objects could have formed within just a few hundred or thousand years. Regardless of how Pluto formed, current research indicates that its ocean is likely sustained by the heat generated from radioactive decay within its rocky core, situated beneath a dense icy shell. This study underscores the deep insights that can be derived from geological observations of celestial bodies. Furthermore, if the hypothesis regarding Pluto's hot start proves accurate, it could have meaningful implications for other dwarf planets in that region, such as Eris, Makemake, and Haumea. So, if Pluto formed rapidly and under intense heat, these neighboring dwarf planets might have undergone similar processes, potentially resulting in the presence of oceans comparable to Pluto's. Now, the question is, should we reconsider Pluto's planetary status? In 2006, the International Astronomical Union, IAU, downgraded Pluto from a planet to a dwarf planet. The IAU's definition of a planet requires that an object be in orbit around the Sun, have sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium, or nearly round, shape, and has cleared the neighborhood around its orbit. Pluto meets the first two criteria, but it does not meet the third criterion. But ever since the New Horizons probe returned the first images of Pluto, some astronomers believe that Pluto must be reclassified as a planet. They argue that the IAU's definition of a planet is too arbitrary. The definition of a planet should be based on the intrinsic properties of an object rather than on its dynamic relationship with other objects in the solar system. Under this definition, Pluto would clearly qualify as a planet. It has a complex surface with mountains, valleys, craters, and even a subsurface ocean. This suggests that Pluto is geologically active, a characteristic of planets. Also, Pluto has a thin atmosphere and a system of moons. This means Pluto has enough gravity to hold on to these objects, another characteristic of planets. What are your thoughts about it? Intriguingly, the discovery of subsurface oceans not only deepens our understanding of celestial bodies, but also raises the tantalizing prospect of habitable environments beyond Earth. Subsurface oceans provide a haven for life to thrive, shielding it from the dangers of catastrophic impacts and harmful radiation exposure. This study has suggested that Earth may not be the only oceanic world in our solar system. Instead, numerous oceans could thrive beyond our current understanding. However, to validate these possibilities, future observations are necessary, and only then can a definitive conclusion be reached. Thanks for watching, and if you would like to support us, check out the link in the description.